Okay, welcome everybody. Does anybody have any questions? Today is about our fifth class, I think, fifth or sixth. Okay, so we're going to continue with the same structure as last week. So we're going to have a short lecture, between 4 and 6 minutes, and then we'll have some questions to follow that. So let's give that a try. Okay, so last time we were talking about functions, so I want to continue with that. I'm sorry, last time we were talking about inverses of functions, and I want to continue with that. So let's just see what's on this screen. So we have a function, I don't know if you can see this, it says a and b, and the name of this function is f, and the domain of f is 1, 2, 3, 4, and the range is 10, 7, 4, and 2. And so first of all, we write f goes from A to B. So that means that the domain of f is A and the range is B. And we said that like we can write f of 4 equals 10, or we also say the image of 4 under f is 10, And we can say the same sort of thing with this one, f of 3. And then we talked about what we meant by the inverse of f. So the inverse of f is a function which goes from b to a instead of from a to b. So it goes the opposite way. So instead of saying f of 4 equals 10, f of 4 equals 10, we'll say f inverse of 10 is 4. So it goes in the opposite direction. So we have this notation that we use, f with a negative 1 up here, and that stands for the inverse. And then we started to look at this function, or maybe no, we didn't start yet. Did we do this yet? I don't know. I don't remember. Let's continue now and see where we are. Right, we have, for the inverse, we're going to have 4 going to 2 places. Okay, sorry. So this function g is g of 4 is 10, g of 3 is 4, g of 2 is 4, and g of 1 is 2. So we have some of that information. G of 4 is 10, g of 3 is 4, and g of 2 is 4. So if we talk about the inverse, which would go from b to a, then we'd say g inverse of 10 is 4. So we wrote that g inverse of 10 is 4. But then we get to g inverse of 4 is 3, and g inverse of 4 is 2. That's a kind of a problem. So let's see what happens. So that's not a function. So in that case, we say that this original function, does not have an inverse. Does not have an inverse. Okay? So if you end up with, when you consider the inverse, if you end up one thing going to 2 places, that's a problem. And so we say it doesn't have an inverse. So when does that happen? When you look at the inverse, you have one thing going to 2. When does that happen? That happens here when 2 things go to 1. Now 2 things are allowed to go to 1. This is a function. G is a function. 2 things are allowed to go to 1. Remember, the problem for functions is not that 2 things go to 1, but that 1 thing goes to 2, right? 2 things are allowed to go to 1, but 1 thing is not allowed to go to 2. So this is not allowed, but this is okay for a function. But when we have 2 things going to 1, then we don't get an inverse. So when we have 2 things going to 1, we're going to give that a special name, and then say when that happens, we don't have inverses. So that name is called a function. Well, actually, sorry. as long as two things don't go to 1, we're going to give that a name. A function is called 1 to 1 if when f of a equals f of b, that means that a must be equal to b. In other words, the only time f of one thing can be equal to f of something else in the domain, a and b are in the domain, is if those two things are actually the same point. You can't have. Okay, let me ask everyone. For this function g, is this true or false? So for this function g, is this statement true or false? In other words, not f, but g. Is this true for g or not?
It's not true.
Not true.
No, it's not.
Okay, so I got 3 not. Any people want to say it is true? Does anybody want to say it? They don't know? Is there anyone who wants to say they don't know? All right, well, I'll explain it anyway. Okay, so let's check this. So is f of a equal to f of b? Does that mean that a has to equal b? Well, let's see. How about this is a and this is b? So 4 and 3, a and b. Is f of a equal to f of b in that case? Or g? G or f, it doesn't matter if I call it g or f. So let me say it again. If this is a, if 4 is a, and 3 is b, is f of a equal to f of b? Or g of a equal to g of b? I can't hear that. Let me ask it again. Here's a is 4, and b is 3. Is g of a equal to g of b? No, right? Because g of a is 10 and g of 3 is 4. So we don't have to worry about that. We're only talking about the case where f of a equals f of b, or g of a equals g of b. So let's try for this one, for this pair. This is a and this is b. So a is 3 and b is 2. Is g of a equal to g of b?
Yes.
Yes. Does that imply that a equals b? Is it true that 3 equals 2? No. Okay, so because that we found the case where f of a equals f of b, but it's not true that a equals b, because we found such a case, we can't call this 1 to 1. Does everyone get this definition of 1 to 1? Is that clear? I'll say it once more. Here's a and here's b. So a is 3 and b is 2. Is it true that g of a is equal to g of b in that case?
No.
Huh?
Yes. Yes.
Yes. Yes, it is true that g of a equals g of b because g of 3 is the same as g of 2. But if we want to call it this function 1 to 1, then whenever g of a is equal to g of b, it has to be true that a equals b. Well, it's not true here. A is not equal to b. A is 3 and b is 2. They're not equal. So therefore, we cannot call this function 1 to 1. Is that clear?
Yes.
So 1 to 1 means that you don't get this kind of action where two things go to 1. In other words, you can't have two separate things, A and B, going to the same place. So this is called 1 to 1. Basically, it just means that you don't have this. you don't have this. If it's 1 to 1, you don't have that. Okay, you don't have A and B both going to the same place. The only way that A and B can both go to the same place is if A is actually equal to B. That's what this says. If f of A equals f of B, then A actually has to equal B. So that's called 1 to 1. So now we can say a function which is 1 to 1 has an inverse. And a function that is not 1 to 1 does not have an inverse. If you want to think about this visually, when you have two things going to 1, what does that mean in terms of the graph? It means you have two things, A and B, for example, going to the same height. So in other words, if you had a picture like this, so is that 1 to 1? No, it's not, because, for example, A, let's see, A, this A here, and this value here, well, if I drew it right, both go to the same height. So you have two things going to the same height. So just like before, when we wanted to see whether whether something was a function or not, we had a visual test. Remember, we said this is not a function. The visual test was check a vertical line. If you can cut it in two places, then it's not a function. Now we can check, well, now we can have a visual test for whether something is 1 to 1, and that is if you can draw a horizontal line and cut it in two places, then it's not 1 to 1. So that's a test for 1 to 1. We could call it the horizontal line test. So let's just do an example to check to see if a function is 1 to 1. So we could do the horizontal line test, but let's just do it with the original definition. So let's suppose we take the function f of x equals x squared, and the question is it 1 to 1? Okay, so is x squared 1 to 1? Is x squared 1 to 1?
No.
No, and we know that by the vertical line test. This x squared is a parabola. This might be an inverted parabola, but a parabola is going to have the same problem that this does regarding the horizontal line test. But let's just check it a different way. And of course, we know it's not, because it looks like this, or it could look like this, and that's not 1 to 1. But let's do it with the definition up here. So what do we have to test? For example, is f of 1 equal to f of negative 1? So is that true? Because, of course, 1 is not equal to negative 1. So if f of 1 is equal to f of negative 1, that violates this, because if this is equal to this, then we said they have to be the same. But here, 1 and negative 1 are not the same. But what about f of 1? Is that equal to f of negative 1? Yes, of course it is, right? They're both equal to, this is equal to 1 squared, this is equal to negative 1 squared, and they're both equal to 1. So in other words, what we're saying is that negative 1 and 1 both go to the same height, and so that's not allowed. So this function, x squared, y equals x squared, is not, this is another way to write it, 1 to 1. Okay, so let's write down what we've said. So it's not 1 to 1, therefore what? It doesn't have an inverse, right? So x squared will not have an inverse. Said, if f is 1 to 1, then f inverse exists, and if y equals f of x, where f goes from a to b, so a is the domain and b is the range for f, then f inverse of y equals x, where f inverse goes from b to a. So this is what we mean by the inverse. Okay, where is x? Is x in a or is x in b? Where is x? Is x in a or is x in b? Okay, you can speak instead of type. I don't want to have to check the chat box.
A.
Okay, it's in A.
A.
Good. It's in A. Okay. And how about Y? Is Y in A or in B?
B.
B, right? So
B.
X is here in A and Y is here in B. So when we go backwards, the inverse takes elements from B. So in other words, takes the Y's and sends them to elements in A, sends them to the X's, right? So we can write F inverse of Y is equal to X. Inverse of this function. So if y equals f of x, then f inverse of y equals x. Okay, let's have a quiz the domain now. Right, we have for the inverse, we're going to have 4. Oh, it's messed it up. Okay, I guess I go to here maybe. Is the domain and okay. Okay, so let's have a quiz now. So or an exercise, maybe I should call it. So let's do it in groups. Now, in the groups, the idea is for you to, if you know how to do it, that you explain it to someone else the best that you can. Of course, you may not be able to explain it that well, but if the best that you can, and not that you just give the answer, but you explain the reasoning if you can. If you can, you explain the reasoning to the other members of the group that don't have a good grasp of the answer. Okay, that's the idea. So let's try it out. So, okay. Okay, so I will open the rooms and then check Manaba for the question.
I think that we cannot see the test.
You can't see the test?
Yes, it's already been closed.
Ah, there's a time on it.
Yes.
Okay. Somebody put times on all of these. Okay, I have to fix that. Okay, this is, and I don't know why, but in this class I have endless problems. Let's see. Okay, and let's see, I need to go to, okay, I have to get rid of the time somehow. Okay, let's see. Today, okay.
Let me check.
Okay. How about now?
Nothing, I guess.
You still can't see? Oh, I
Yeah,
didn't turn it on yet.
nothing.
Yeah, yeah. Oh well, someday this might work. I don't know when. Let's see. Inverse function. Okay, let me try it now. Okay, now. Can you check it now?
Yes.
Now it's there, right?
Yes.
Okay, sorry about that.
Okay, thank you. Mm,
Let me leave this room.
oh, you can leave the room.
Let me break up. Okay, you can just do it. I apologize. There was these tests all have a time on them, and the time has nothing to do with our class. So they are locked, or they were locked, but I unlocked this one, so you can just do it yourself. So you can do it now. Should be able to do it.
Professor,
Yes.
I have a question about the quiz.
Uh-huh.
I think I put the right answers, but it said it's 0. The function is 1-to-1, but
Okay, let's see. I hope it's not wrong.
it's not 1-to-1.
But given the way things have been working in this class, it could be. I don't know what's wrong, but let's see. I'll check it. So Okay, so the questions were, is the function below is 1-to-1. So what about that? Is it, do you remember, maybe should I share my screen? I guess I'll share my screen. Let's see. Let me share the screen. Share the screen here. Down here. And let me show you the problem. Okay, can you see that?
Yes.
Okay, so the it says, is this 1-to-1 or not?
No, it's not.
No, it's not.
No, it's not 1-to-1, right? Because we have 2 going to the same value. Is that what you said?
Yeah, it's false.
You said false?
Yeah.
And it said you were wrong?
Yeah, yeah.
Everybody else agree?
Yeah, mine also is wrong.
Yes.
Wow, okay. Okay, have to fix that. And the next one, how about this one? Is this function 1-to-1?
It is.
Yes.
And it said you got it wrong?
Yes.
Yeah.
Yes.
Okay, well, it seems like no matter what I do in this class, I can't get the systems to work very well. My other classes are working pretty well, but this one is not. Anyway, okay, I will take care of that. Okay, so then the answers should be, as many of you have said, this function is not 1-to-1, and this function is 1-to-1. Are there any questions from anybody about why it's true? Okay. All right, let's go then. Let me close this one. Sorry, I should have closed it already. And let me go to the next one, which is you can do without going into the groups. Okay. So just a second, I'll turn that on. Okay, go ahead and try that. Oh, no, sorry. It has it. Oh yeah, you should be able to see that, right? Can you see that?
No.
Yes.
Okay. Okay, good. So you can try that.
Professor, again there was some problem.
Yes, Professor.
Oh God. Okay, I'll look into this during the next lecture, next video. Okay, I'm going to turn it off now. And now I'm going to share it with you. And we'll see what we have to say about it. Wait. Not many people entered an answer. Let me open it again. Okay, can everyone enter their answer?
We can now.
Okay, so go ahead and do that one. Okay, I'm going to shut it in 20 seconds. Okay, in 5 seconds. Okay. Okay, let's go through that one. Okay, so what about the function passes the horizontal line test, true or false?
False.
False.
False. And the function is, if a function is 1-to-1, it has an inverse.
True.
True.
Okay, did that work, or the answers were wrong?
We could not see answer.
We cannot see.
But the last time you saw the answers, but this time you didn't?
Yeah, last time.
Last time, some quizzes also we didn't see the answers. So.
No, I mean, sorry. Just 5 minutes ago, you could see your answers?
Oh, the grade was published last time, but this time I don't see the grade now.
The grade was published 5 minutes ago, but this one doesn't have a grade?
Yeah.
Okay. All right. Okay, let's keep going. Maybe. All right. Let's keep going. Let's check this lecture. Continue with inverse functions. Is the domain, and B is the range for f. Then f inverse of y equals x, where f inverse goes from B to A. So this is what we mean by the inverse of this function. So if y equals f of x, then f inverse of y equals x. And let's just state this clearly, what we've noticed already, and that is the domain of f is equal to the range of f inverse, right? The domain here of f was equal to the range of f inverse, and the range of f is equal to the domain of f inverse. Okay, now let's think about what would happen if I did f of, well, let me do it the other way, f inverse of f of x. So sorry about this, let me erase that. Okay, so what would happen if I did f of f inverse, I'm sorry, f inverse of f of x. So what would happen? So if I do f of x, let's take an example. Let's say this is f. So we can see that f of 1 is equal to 5. Okay, so let's see what happens. So I put in, do f of 1, and then take that and put that into f inverse. So what's going to happen? So I do f of 1, gives me 5, and then I do f inverse. This is f inverse. So I'm putting in 5, so what do I get back? 1. So I started with 1, I put it into f, I took that result and put it into f inverse, and I get back 1. Let's try it again. Suppose I do f inverse of f of 3. So I'm putting 3, which is in the domain of f, into f, and I get out 7. So this part here 7, and then I'm putting that into F inverse. Well, here's 7. It takes me back to 3. And let's do it with the next one. F inverse of F of, let's put in 8 into F. So what happens? I put in 8, I get negative 10, and then F inverse takes negative 10 back to 8. So I get 8. So if I do F inverse F, it's like doing nothing at all. I mean, if I start with X and I do F and then F inverse to it, it just gives me back X, right? So we can say that this is just equal to X, okay? And of course, it's the same thing if you do it in the opposite order. That is, if you do F of F inverse of X, what's that going to give you? That's also going to give you X. Let's check it. So let's try F of F from B in there. So we put that into F here, but that takes it back to 5. So it's the same thing whether you do F first or you do F inverse first. You still get X. Okay, so let's just talk a little bit about logic. Okay, which one is correct here?
Third one?
The third one.
Right. So it doesn't matter which order you do it in, you get the same result. In fact, okay. All right, let's do one more now. Any questions about this?
No.
Okay, let's do one more. Here's another one. So try that one on your own. Okay, let's close that in 15 seconds. Okay, I'm going to close it. Okay, and here's the question. Which is the correct one?
Second one.
Second one. F.
Second one.
If you do the two of them together, it's like doing nothing. So you put in X and then you do both of them, you just end up with X. Okay, now we take a digression here and we talk a little bit about logic. So let's take a look at that. Logic. So you know that in mathematics, we often have statements like this. If P, then Q. Now we just had an example of that. We were talking about one-to-one functions, and we had if f of A is equal to f of B, then A must equal B. So that's of this form. If P, then Q. This would be P, and this would be Q. Anyway, in mathematics, we often have forms like that. So we can also we can take this and we can represent it with symbols like this. So this is red, exactly like this. This is red. If P, then Q. And if we wrote, for example, if we wrote this, this would be red. If Q, then P. And if I had R and T, this would be red. If R, then T. Okay. So, so what's the relationship between a statement like P arrow Q, meaning if P then Q, and the statement Q arrow P? So is there a relationship? I mean, are they logically the same? Do they mean the same thing? So before I go on, what's the answer to this question? Does P arrow Q mean the same thing as Q arrow P? Are they equivalent, logically the same?
No.
No. So let's see that. Well, let's think about it. Let's suppose we say P is I am in Tokyo, and Q is I am in Japan. Okay, so what does this say? If P, then Q. So what is that? If I am in Tokyo, then I am in Japan. Let's just write it out. If P, so if I am, I'm working with this one, not this one. If if I am in Tokyo, then I am in Japan. Okay, so that's what that means. So actually, that's true, right? That has to be true, but it's not. I'm not really worried about whether it's true or not. I just want to write it down. So what does this mean? Q arrow P. So that's if P, then Q. So sorry, if Q, then P. So if I am in Japan, then I am in Tokyo. Okay, so what about these? Are these the same? No, they're definitely not the same. I mean, they don't. One is, in fact, is true, and this is not necessarily true, right? So they can't be the same. So the point here is that P arrow Q and Q arrow P are not the same. They're basically different statements, and if you prove one of them, if you prove this statement, for example, if I prove, what did we have up here? If I prove this, where this is P and this is Q, that's not the same thing as proving Q arrow P. Right? I'd have to, if I wanted to say, if A equals B, then this equals that, that's a separate proof. I'd have to show that separately. They're not the same statement. P arrow Q is not the same as Q arrow P. Okay, however, is there anything that's related to P arrow Q or actually logically the same as P arrow Q? Well, consider this. Q, not Q, I'm sorry. This means not. This means not. So consider this, not Q, arrow, not P. Okay, this is logically the same as this. So let's take an example. Let's take the example that we just had, which was if I'm in Tokyo, then I'm in Japan. And let's write this one now. So what does it say? If, this is not Q, Q was I'm in Japan. If I am not in, what was it? Not in Japan, not Q, then I am not in Tokyo. Okay, so that seems basically like the same sentence as the original one. If I'm in Tokyo, then I'm in Japan, and if I'm not in Japan, then I'm not in Tokyo. They seem the same, whereas these two did not seem the same, right? If I'm in Tokyo, then I'm in Japan seems very different than if I'm in Japan, then I'm in Tokyo. In fact, this one is not true, and this one is. But this is very close, and we say it's logically the same as this. Okay? So again, this says if I'm in Tokyo. Sorry, that's a mistake. What's the mistake I just made?
It's not Q to P, but P to Q.
So not Q, arrow, not P. I just said it's logically the same as that. That's not right. Not Q, arrow, not P is logically the same as P, arrow, Q. Okay, let me say it again. Not Q, arrow, P. This one here is logically the same as this one, P, arrow, Q. Okay, does everyone follow that? This one says, if I'm not in Japan, I'm not in Tokyo. That is equivalent to, if I'm in Tokyo, then I'm in Japan. Those two are logically the same. So, okay. Tokyo, then I'm in Japan. This says if I'm not in Japan, then I'm not in Tokyo. So we say they're logically equivalent. So if you want to prove this, you can choose to prove this instead. This might be for some reason easier for you to prove than this. And so if you prefer to prove this, that's equivalent to proving this. Okay, So this thing has a name. It's called the contrapositive of the original statement of P arrow Q. So this is called the contrapositive of this, and a statement and its contrapositive are logically equivalent. So if you want to prove this, but this turns out to be easier for you to do for some reason, you can prove this instead. You can prove the contrapositive instead. Okay, everybody, what's the contrapositive of P arrow Q? What's the contrapositive of this, P arrow Q?
On Q arrow not.
Not Q arrow, not P.
Right. Now, let's say it again. So the contrapositive of this one is this one. It's not Q arrow, not P. So how do I form the contrapositive of a statement? How do I form the contrapositive of a statement? Here's a statement, P arrow Q. How do I form its contrapositive? So
Exchange the places and
right.
add not.
Right, okay, exactly. So exchange the P and the Q. So put the Q here and the P here, and then preface each of those with the not symbol, right? So that's exactly what we did. So if we have P arrow Q, we we have P first and Q second, and we make Q first and P second, and we preface each of those with a not. And that gives us the contrapositive. Does everyone follow that?
Yes.
Yes.
Okay, so tell me then, form the contrapositive of this one. You just told me what the contrapositive of this is. Now make the contrapositive of this.
P arrow Q.
Yeah, it's P arrow Q. I forgot to mention, but I think most of you would know that not means what? Not is like negative in the sense that if you do negative, you get nothing, right? Right? Negative is like doing
Yes.
nothing, and not is like doing nothing, right?
Yeah.
Yes.
So if you get the contrapositive of this, let me just do it here. So let's do it here. Let's get a new sheet here. I can. If I can't. New page. Okay. Let's do that. So let's just write this. So if I have P arrow Q, we said that to get the contrapositive, you switch the order, and then you preface each one by not. So now what I'm asking for is to give me the contrapositive of this. So what do? I want the contrapositive of that. What do? I switch the order of this and this. Okay, I'll switch the order. Not P and arrow, not Q. But then what do I have to do? I have to preface each of those with not. So I get not and not. So, but not is the same as P. So I just end up with this. So the contrapositive of this is this. Everyone follow that?
Yes.
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 So the contrapositive of P arrow Q is this, and the contrapositive of this is this, okay? And P arrow Q and its contrapositive are logically the same. So whenever you have some math proof that you have to do, it's almost always going to be of the form if P, then Q. If you prefer, you can prove if not Q, then not P. That will be okay. That will be still proving the same thing as the original task. Okay, does everyone understand this?
Yes.
Yes.
Okay, so we're allowed to do that. We're allowed to prove the contrapositive. One more thing, may as well just go through it here. Let's go to here. And one more thing, and that is, we just said P arrow Q is not the same as Q arrow P, right? They're not the same, right? We said what this is, if I'm in Tokyo, I'm in Japan. Tokyo, Japan is not the same as if I'm in Japan, then I'm in Tokyo, right? Everyone get that?
Yes.
Yes.
This is true, and this is not even true, so they can't be the same, right? So this is not the same as this, right? Everyone agree with that?
Yes.
Yes.
So this has a name also. Remember, if we start with this and we write not Q arrow not P, that has a name. It's called the contrapositive, and this one also has a name. This is called the converse. Okay, so the statement and its converse are not the same. Okay, does everyone understand that? So you often hear, like in English, people will say blah, 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 and then they'll say, and conversely, something else. Okay, I'm sure you must have heard that sometime. They'll say da 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 da, and conversely da 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 da. Right? Have you ever heard that? No? Anyway, well, you could say that yourself. You could say blah, 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 and conversely, something else. So you're saying, you're not just being wordy when you say, and conversely this, because you have, if you say this, and then you say it's conversely, I'm sorry, if you say this, and you say it's converse, it's not like just saying the same thing. If you say this, and then you also say the converse is also true, that's not just being redundant, right? You're saying something else is also true, because the statement and its converse are not the same thing. So if you assert a statement and its converse, you're not just being redundant, you're saying something new when you say the converse is true. Okay? Does everyone follow what I'm saying?
Yes.
Maybe?
Yeah.
So, but it would be stupid to say blah, 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 and contrapositively, I mean, nobody ever says that, but, and contrapositively, you wouldn't need to say the contrapositive. It's always going to be true. So you wouldn't have to say and contrapositively. You don't need to say that. But if you want to also say the converse, you have to say that it's also true, because it's not logically, doesn't follow logically from the original statement. So the converse does not follow from the original statement. Okay, anyway, so this is the original statement. This is called the converse, and this is called the contrapositive. Okay, let's see, do we have anything about this? I don't think so. Oh, we do. Okay, let's do let's open up the rooms again. And you can check this one. Hopefully it will work.
Yes, sir.
Yes.
So what should we put for the second one? Anything is fine.
Yeah, anything is fine.
Okay.
Professor.
1 second, please. Okay. So it looks like the second question didn't show up properly. But anyway, what's the answer to the first question? Oh, sorry, before you answer that, let me close it. What's the answer to the second problem? I'm sorry, the first problem?
2.
Two.
Yeah,
The
2.
second one.
This is contrapositive. And let me just ask you, which is logically equivalent to the original statement, the contrapositive or the converse?
The contrapositive.
Right, the contrapositive. So this and this are the same, logically the same. So I preface it with the word logically, because maybe it doesn't sound the same, maybe it's not as beautifully written or something like that, right? Maybe one is more poetically better. They're not poetically equivalent, but logically they are equivalent. Okay? Okay. Now let's see what the next question. Okay, let's try one more as a individual question. So check that now. Okay, 15 seconds. Okay. Okay, let's look at that one. What's the answer here? The contrapositive, if I live in Tokyo, then I live in Japan. The contrapositive is?
The second one.
Number 2, right. If I don't live in Japan, that's the reverse of the second part, the negation of the second part, then I don't live in Tokyo. Okay, contrapositive. Okay, let's continue. Like this, because they're equivalent. Okay, let's look at this function. X squared, f of x equals Okay, x hopefully it'll squared. get clear in a minute. And let's just take a few elements in the domain, not every possible real number. Let's just say 1 and 2, 3, and let's do -2. So 1 goes to 1, 2 goes to 4, 3 goes to 9, and -2 also goes to 4. Okay, so this function, we already said, is not going to be, it's not going to have an inverse because it's not 1-to-1. Okay, so however, if we limit the domain to only positive numbers, then what? Then we don't have a problem. So let's have just 1, 2, 3, and over here we can have 1 goes to 1, 2 goes to 4, and 3 goes to 9. So if we limit the domain like this, we don't have that problem. This is for x squared. And we have this function. Okay, now, and this is y equals f of x equals x squared. Okay, so what would be the inverse of this? For example, what function will take 4 to 2, 9 to 3, let's suppose we had 5, that would have gone to 25. What function, the inverse, what is this inverse function? I guess we want to write x, maybe we should write, I guess we want to write y equals x. What is this function though? So I think it's pretty clear that f inverse is the square root of x. But I've been writing, I should have written f of y equals x, but now I want to write f inverse of x just because it looks weird to write f inverse of y equals the square root of y or the square root of x. In either case, it would look strange. So I want to write this as though it's just a regular function, and that we usually put x for the input. So so this function is the square root of x. So in other words, if you have x squared, the inverse of it is the square root of x. That is, if we limit the domain like this. If we have this, we can't talk about the inverse. But if we limit the domain only to positive numbers, we can talk about the inverse. And the inverse is the square root of x. So what if the function had been not x squared, but rather f of x equals x cubed? So what would be the inverse of that? So let's, in this case, actually, we don't have to limit the domain, but let's ignore that. Let's just keep the domain limited. So let's just say 1, 2, 3, and 4. And so 1 goes to 1, even when you cube it, but 2 goes to 8, and 3 goes to 27, and 4 goes to 64, I think. 64. Okay, so if that's f, what is the inverse? So the inverse takes 8 to 2, 27 to 3, 64 to 4, and 1 to 1. So what is that function? I think you probably recognize that that is the cube root of x. The cube root of x. Okay? So if we start out with x cubed, the inverse is the cube root. And this makes sense, right? That is to say that x squared and the square root of x, and the square root of x are inverses, and x cubed and the cube root of x are inverses. That makes sense, because if you do, remember we said that if you do f inverse of x, you should get x, or we also said if you do f of f inverse of x, we also get x. So we're saying if I, let's say, let's work with this one. So if I do x, f is equal to x squared. So if I do x squared, that means I'm squaring here. I'm squaring the inverse of x. What does the inverse of x have to be in order to get x back? It has to be the square root. So if you do the square root of x squared, you get x. And so squaring and square roots are inverses. These two are inverses. Same thing here. Cubing and cube roots are inverses. Okay, I think that's pretty clear. So, okay, so let's go on and let's see about this. Okay, let's go to our groups again. Okay, groups, groups. Okay, and check the exercise. Okay, sorry about that. I want to give you one more piece of information before you do that exercise. Let me just go through this a little bit more. Equals 3x. What's the inverse going to be? It turns out that the inverse is going to be 1/3 x, or x over 3. So let's check that, see if that works. Okay, so let's say, let's check this, f of f inverse of x. So f inverse we're suggesting is x over 3, and then you're putting that into f, but when you put that into f, you multiply it by 3, so you get 3 times x over 3, which is x, so that works. So the inverse of 3x is x over 3, and of course the inverse of if f of x was equal to, for example, 10x, the inverse is going to be x over 10. Let's try another one. The inverse of 3x is x over 3, and of course the inverse of if f of x was equal to, for example, 10x, the inverse is going to be x over 10. Let's try another one. What about if you have f of x equals x plus 10? So you might ask, what's the inverse of that? And that is going to be x minus 10. So let's check that. So let's do f of f inverse of x. So what do you get now? So you're putting in f inverse. So you want to put in f inverse, you want to put in x minus 10 into f. But what does f do? It takes whatever you put into it and adds 10 to it. So we're going to take this and add 10 to it. So we're going to take x minus 10 and add 10. What do we get back? We get x. So it is true that this and this are inverses. Okay? Okay, now, so here's a trick for, okay, so now let's go back and do that question. Okay, I'm going to close this. So what's the answer to this one?
None of these.
Right, this one here, none of these, right? Because the inverse of this we just said was 10x, or actually we said the other way around. The inverse of 10x is x over 10, so they're both inverses of each other. Okay, let's continue. How to get the inverse if you can't figure it out. Like, it's a little bit hard to figure out. Suppose I give you this one, f of x equals 2x plus 8, and I ask you for the inverse. A little bit hard to figure that out. Like, just 10x is okay. We can see that it's going to be x over 10, or just x plus 10, we can see it's going to be x minus 10, but this is a little bit complicated. So it turns out that what you can do, and you might be able to see this, is, so here we started out with this function, 2x plus 8 equals y. To get the inverse, you switch x and y. What do I mean by switch x and y? You write 2y plus 8 equals x. Now, there's no, when we learn algebra, we have like x plus y equals 6, and you want to solve for x, so you would subtract y from both sides. sorry, subtract y from both sides. So you'd end up with like x equals 6 minus y. And so you would have solved. So we always say you're allowed to subtract y from both sides. We have never said, you never say, that you can switch x and y. That is, you have 2x plus 8 equals y. There's no rule that says you can switch x and y, because you can't switch x and y. This is just how to get the inverse. The inverse is not the same as the original function, and you cannot switch x and y. But if you want to get the inverse, you can switch x and y to get the inverse. So that's what I did here. 2x plus 8 equals y. 2y plus 8 equals x. That will give you the inverse. Now, if you want to get the x, you want to write it like y equals something, you have to solve this for y. You're not going to get this back again, because you switched x and y. So if you want to do this, you'd write 2y equals x minus 8, and then you'd write y equals 1/2 x minus 4, right? So that is the inverse. So let's just make sure that that really works, because we already did the work for example, I think we said if we started out with f of x equals x over 10, we found out that the inverse was going to be 10x, right? So let's see if that little trick worked. So we start out with this function. In other words, we start out with y equals that. We start out with y equals x over 10. And the trick was to switch x and y. So if you switch x and y, what do you get? You get x equals y over 10. Now solve for y, and you get what? Y equals 10. Y equals 10x. So that's what we thought. If we start out with x over 10, the inverse was 10x. And that's what we found here. So that's just a little trick to find inverses. You switch x and y and then solve for y. So let's try something. Let's try this. And let's try graphing a function and its inverse. And okay, let's go to, before we do that, let's look at this one. Okay, let's go back and do a group exercise. Okay, I'll turn that off. Okay, so what's the answer to part 1?
Different function.
Right, they're different functions. And what about part 2?
Different
Two
answers.
different
Right.
functions.
They're also different. Let me just drive this point home a little bit. Let me just make this point a little bit more clearly. So let's suppose that I have this function like y equals 2x plus 3. Okay, so of course you know what the graph of that looks like. It has 3 here, and it has a slope of 2, right? Everyone knows this, right? Okay, so now what happens if I divide everything by 2? So we know in algebra we can divide or multiply everything by 2, right? So I can multiply the left-hand side by 2 and the right-hand side by 2, right? Everyone knows that. So I could write, for example, 1/2 y equals, then I'd multiply this side by 1/2, right? 2x plus 3. So then I get what? I get 1/2 y equals x plus 3 over 2, right? Everyone knows this, right? So what if I graph this thing? What's it going to look like? What's the graph of this going to look like? Anybody know what the graph is?
It will be
Anybody?
same as the previous one.
Oh my God, it's going to be the same as the previous one? Yeah, that's right, of course, right? Because what do we mean when we say we can multiply both sides by 1/2? We mean that we don't change the equation, or we don't change the set of solutions, right? For example, one of the solutions to this equation is this point, right? What does that mean? It means when x is 0, y will be 3. That's what we mean. So, of course, when I put in 0 here, I get 3. So one of the solutions to this is 0, 3. Another solution is whatever this point is. Another solution is whatever this point is. In fact, this graph is just a picture of the set of solutions to this equation. And when we multiply by 1/2, we don't change the solutions. So we're going to get the same graph. Okay, so that's what we mean by we can multiply everything by 1/2, or we can also do something like add 5 to both sides of the equation if we want to, right? We don't change the solution set. But when you do this, when you start with this, and then you switch x and y, nobody ever said you can do that. And the reason nobody ever said you can do that is not one of the operations that preserves the set of solutions or preserves the solution set to the original equation. You don't preserve the solution set if you change x and y. You're going to get a completely different graph. It's not going to be this graph anymore, and the solutions are not going to be the same. So you cannot switch x and y. And that's not an algebraic rule. What we said is if you switch x and y, you will end up with the inverse function, which is a completely different function. Okay, so I just want to make that point clear. Now let's go to this, and let's try graphing a function and its inverse. So we had the function was x over 10. So what does that look like? That looks something like this. Let's see if I can do this. So it has a low slope, a small slope, because that slope is 1/10, and the inverse is what? Y equals 10x. That's kind of a large slope. So we can go like this. So that is the function, the one function and its inverse. Okay, suppose we do another one. Let's try another one. Let's draw another graph. Okay, and we did another one, I think. we had x minus 10 and x plus 10 were inverses. Let's write those down. Y equals x minus 10 and y equals x plus 10 were inverses. So let's try that. So here's 10. So let's graph this one. So that has a slope of 1 because the, so it looks like this maybe. Slope of 1. Okay, and then what about this one? So y minus, y equals x minus 10. It's like here. That also has a slope of 1. So let's see if I can put that in there. So let's say it goes approximately here. Well, I'm going to do that. Okay. So that's a function and its inverse. Okay, and let's try another one. I think we did, like the first one we did, I think was y equals x squared. We had y equals x squared, and we saw that the inverse was y equals the square root of x. Now, y equals the square root of x, I'm not very good at drawing, but it looks something like this. Okay? And y equals x squared, of course, we know, looks like that. Okay, so we have a function, let's call the original function x squared, and this is the inverse. Okay, and then over here, we also had the function and its inverse. And over here, we also had a function and its inverse. So there's a pattern here. We can see a way to visualize what the inverse of a function is going to look like. So let's see, what are we talking about here? So we're talking about that if we draw this line, which is supposed to be a 45-degree line, and we reflect this one through this line, we get this one. And the same thing happens here. If we reflect this one through here, we get this one. And the same thing happens here. You can see that if you reflect this one through this blue line, you get this one. So we can see that there's a very nice relationship between the graph of a function and the graph of its inverse. Okay, they are reflections through this 45-degree line. That to obtain the inverse. Okay, so that's all for today. I will adjust your homework and we'll come back, finish up inverses, and continue where we left off. We did talk about limits a while back, so we'll continue with that next time. So see you then.
Thank you, Professor.
Okay, see you next time.
Is respond closed?
Slowly we'll get the system working so that we don't have too many glitches.
Professor, can I have
Yes.
a request to reopen the card of the response? I didn't
Sorry?
check my stat.
What did you
The
say?
response code. It has been closed and I couldn't give my attendance.
Which thing?
The response code.
Oh, the response code. Okay. You have to ask our TA.
Okay, I will open.
Okay, thank you.
Professor?
Yes?
Like response saying we have given the attendance to intro to statistics, and is it okay?
No, sorry, like I will give you the another response code.
Okay.
Sorry.
Anybody else?
Professor.
Yeah?
Can you open the third quiz, like the inverse function part 3? I I did not like turn it in time.
Okay. I hope you are paying attention, but yeah, I'll do that. Which one?
The part 3 of invert function, I think.
Part 3. Okay. The individual or group?
The group one.
Okay. Okay. But you generally should do it on time, right?
I just missed the confirm one because
Okay.
the code is so sudden.
Okay, maybe I think it's open now.
Okay.
Group 1 is open, part 3.
Sorry, Professor, I have a question.
Yes, sir.
For the assignments, we are not allowed to ask for extension, right? If we miss a deadline, we cannot redo it.
No. You can automatically get an extension. If you request the extension, you'll get it. You have to request it within I think within 1 week of the due date. If you request an extension, then you will get it, and then you'll have about 8 or 9 days to do it. So you should automatically, there's a button where you can request an extension. Okay, you understand? Hello? Hello? Somebody asked me a question. I don't know who it was.
I think he already left the meeting.
Oh, okay. Anybody else?
Professor, I want to ask one question.
Yes.
About the first group work, that our answer is not.
Yeah, we have to fix that. Yeah.
Is that one gonna count on our grade calculation or?
No, I have to set it or adjust it, so it won't count. Or actually, I think I'll try to set it so that it counts correctly, or else I'll just delete it.
Okay, thank you, Professor.
Okay. Okay, I'm going to stop. I'm going to close the classroom if there are no more questions.
Sir,
Yes.
I have one question. Like, is the score of the quiz gonna be included in the grading?
Yes, definitely. In fact, we don't have many. We don't assign many points for any final test. We might have a final test, but not going to count very much. So the grade will come from your homework and from these quizzes, about 50-50.
Oh, okay. Thank you so much.
Okay. Anybody else? Okay, thank you, Noorzai-san.
Thank you so much, Professor.
See you later.
See you, Professor.